Good morning, all y'all. Morning, Michael. Morning, Mitchell. It's Wednesday of week 3. Hopefully you guys are surviving, figuring things out. Good morning. Schwartzmeyer? Sorry. My face is really bad at hiding like what's going on inside of my brain, so I'm assuming you could tell that I was confused on how to say. Okay, so I was wondering, I was like, wait a minute. Typically, like, Meyer is a last name or Schwartz is a last name. Typically you don't see it together, which is why, hence the confused face. Good morning, Wilcox. It's good to see you guys here. Homework 2 is due tonight. I'm hoping homework 2 is going well, gives you some confidence. Like, you've got this idea that, yes, I can do this programming thing. It's awesome. So for chapter 3 and 4, some of them are optional because 1, there are a million of them, and so we didn't want you to have to do all of them. 2, some of them get pretty challenging, like in sections 4. I know this. In sections 4, 5, and 4, 6, they get pretty challenging, and so they're not quite beginner problems anymore. So part of it's because there's just a lot of them. Part of it is because they do tend to get challenging at the end. That's why. You can always try them if you want to. There's one called interleave mod, which is a great problem, but it definitely is not a beginner problem. Yeah, it's very clever and definitely shows some of the intricacies that you can do with MATLAB. But you're like, the Zybooks problems, they're starting to get into the how do you design a program. Where that's the hardest thing for programmers, for beginner students who haven't coded before, who haven't programmed before, is how do I actually solve this problem using the tools and tips and tricks and rules, essentially, that I've already learned. And interleave mod is one of those where, like, I remember we have assigned it to students in the past, and we just got so many questions, and like the first time I looked at it, I'm like, I know I can do this, but how? So you're starting to get into the ways of how do you design a program? How do you go through the steps? And I'll go over some of those activities today. I think I got through 3 this morning, just to illustrate that. But they get pretty challenging. I'm not gonna lie. It's very intricate. And with arrays in MATLAB specifically, you can do so much. Like, it's just different. Yes. Sorry, FT Remy. Yeah, it is optional. Not all of them are required. So sections 3, 8, 4, 2, 4, 5, and 4, 6 are optional. So Schwartzmeyer, good question. I was planning and hoping to, Remy, if you're interested in the solution, I mean, email me, I can send it to you. It's pretty, like I said, it's pretty, like, it's pretty cool. Like, it's pretty sophisticated. But anyway, so before we get into lecture, Schwartzmeyer, you had a really good question. Homework 1, I wanted to give you guys the grades today. Unfortunately, though, I had an error in the homework 1 solution, which MATLAB Grader is correct. So if you got the checks for MATLAB Grader for homework 1, problem 1, then don't worry about it. You should get those points. but I gave the wrong solution to the TAs and graders. So homework 1, problem 1 is not correctly graded to date. So I can't give you guys the problem, give you guys your grade quite yet. You should have your grade. So, okay, so I made some modifications to the grade book in UBLearns yesterday. I imported your grades from MATLAB or from Zybooks, so you'll see the points from that. However, the total grades doesn't really matter. Like the total number of points doesn't really indicate anything for this class, because you've got what, like 108 points from the first Zybook, 75 from the second Zybooks, but then only 20 points from the homework. That's not proportional. So I put together a weighted grade column where your weighted grade is 5% of your Zybooks points, and then 15 or 20% of your homework, and 5% of your quizzes. That's the only assignments we've had. So your weighted grade shows everything, but if your homework 1 grade is incorrect or not fully graded, it's gonna show as a 73% because it's just not completed yet. So for the first couple weeks or so, don't bother so much with the 73% or whatever percentage you see, or 53.33. Don't bother so much with that. Look at the individual grades. That weighted estimate will update. It will become a little bit more important as we get to the midterm. So once we get to the midterm, then start to look at that weighted grade and be like, okay, like I have this percentage of my grade currently. What might I need on the midterm? So don't worry so much about that. I can't hide that from you. I have to show you either the weighted grade or the total grade, and neither of them mean anything right now. Like, it's not relevant. It's not, that's what your total grade, like at the top where people are saying 53%, 73%, that's the weighted grade. It should be at the top of wherever you find your grades. There's a My Grades tab on UBLearns. I don't know what it looks like for you guys. I don't know how you find things on UBLearns. All I know is where I put things. Especially for your grades. Like, do you go to the My Grades tab? Do you have them in a completely separate location? Like, when you tell me, like, you see the due dates for assignments, like, do you see them in the calendar? Do you see them on, like, the homepage? I don't know where you guys find things. But yeah, so ignore the weighted grade, ignore the total grade. I can't hide them. And they don't mean anything for the first, like, 5 weeks of class because there's relatively few assignments. So don't worry too much about that. I will release your homework 1 grade as soon as possible. Like I said, if you got the check marks in MATLAB Grader for the first 3-4 homeworks, that is an indicator of what your final grade would be. That's not always going to be the case. MATLAB Grader has some limitations. So when we get to homework 5, there will be some additional things beyond MATLAB Grader that you will be graded on. You will see that when we get there. But for the first couple homeworks, if you got all the check marks in MATLAB Grader and you submitted your file correctly, then that will directly correlate to what your score is for your homework. Okay. It's a little longer of an explanation than I wanted, but hopefully all of that makes sense. Hopefully that clarifies some stuff of what you're seeing. I just can't hide everything, unfortunately, until it's meaningful. So just, I made a mistake. I hate making mistakes because that means you don't get your grades right now. So I'm sorry, but that should be updated as soon as possible. We just need someone to regrade 400 some assignments. Okay, let us go ahead and get back into our material. So here we go. We've got our updated split screen. I changed my overlay so it's a little bit more organized. But you can see at the top over here in my notes, that's an indicator of what we're going to be doing, and then I will demonstrate down here in MATLAB how to do it. Okay, My chat this morning in section G wasn't terribly chatty, which to me is an indicator that there's a lot of information. So just, if you don't understand it all right away, that's completely fine. Just in some way, shape, or form, absorb something of what I'm saying, and then you can always come back, you can always revisit. Just try and pick up something as we go along. But there's going to be a lot of information again. So let's go ahead and start with the colon operator. I don't feel like I really did a good job of illustrating how to create vectors with the colon operator, so I want to start there, and then I want to continue into modifying matrices, and then going through some of the challenge activities that you don't have to do. And if you want to stick around at the end, I can show you how to do that interleave mod, Remy. Like I said, it's very sophisticated. So it says here, use the colon operator, create a row vector with the following elements 4, 7, 10, and 13. So it says colon operator. The colon operator works like this. You say your start value, colon, your increment, colon, your end value. So for this vector, I start at 4. I end at 13. And if I zoom in, notice to go from 4 to 7, I add 3. To go from 7 to 10, I add 3. To go from 10 to 13, I add 3. So that means my increment is 3. So in MATLAB, what I would do is I would indicate where I'm starting. So I'm starting at the value of 4. I'm incrementing by 3, and I'm ending at 13. Let me store it in a variable. So if I run this, so I'm going to right-click evaluate selection a lot today. But notice when I evaluate this, when I execute this line of code, it starts at 4, and then it takes 4, adds 3 to get to 7, then 7 adds 3 to get to 10, and then adds 3 to get to 13, and then it stops. For this second one, it says create a column vector with these elements. So once again, same thing. I'm starting at 14, I'm ending at 6. So now to figure out my increment, to get from 14 to 12, I subtract 2. From get to 12 to 10, I subtract 2. To get 10 to 8, I subtract 2. 8 to 6, subtract 2. So that means my increment is minus 2. So that means in MATLAB, I'm going to start at 14. I'm going to increment by negative 2 and end at 6. So now when I execute this line, it gives me a row vector from 12 or 14, minus 2 is 12, minus 2 is 10, minus 2 is 8, minus 2 is 6. If I wanted to make this a column, I would literally just transpose it. Wrong one. So I can just add my transpose. So add that apostrophe, and it will make it a column. If I forgot the minus 2, so let's say I did 14 to 6, notice it gives me an empty row vector. 14 plus 2 is 16, then 18, then 20, then 22. Notice if I have a plus 2, it's going in the opposite direction. If it's not going to reach or approach the ending value, it will give me an empty row vector. So sometimes you just have to try things. So you're sitting there and you're like, oh, why is it not giving me the right answer? And you're like, it's giving me an empty row vector. Like, what is going on? And then just double check, look at your answers, manually figure it out. Take out a piece of paper. Be like, okay, starting at 14, 14 plus 2 is 16, plus 2 is 18. Oh, yeah, that's right. I'm going in the wrong direction. I don't know if you need brackets to transpose. Let's try it. Let's try it, see what happens. Yes, so this transpose, MATLAB gives me a warning. If I hover over it, it says unexpected use of transpose in a scalar context. So yes, so I would use brackets. I could also use parentheses. So MATLAB once again says it here. If you intend to specify expression precedence, use parentheses instead of brackets. So precedence indicates that I want to create the array first. I could use parentheses as well and then transpose it. So either of those will work, brackets or parentheses. That's a very good question. Oops, no, I want that back. Another thing to keep in mind when we do the colon operator, Yes, so colon operator is only for creating vectors with elements that are evenly spaced. Notice someone this morning asked if I did something like this. So if I start at 0 and increment by 12, but I want to end at 4. If I do this, what's going to happen is it's going to start at 0. It's going to add 12, so the next one would be 12. But since 12 is past my ending value, it's going to stop. So it gets as close to, but not past the number. So it's as close to or equals to, but not past. So this is really nice for even numbers and odd numbers. I could say 1 to 12. This will give me all of the odd numbers between 1 and 12. Same thing, I could do 2 to 12, and it will give me all the even numbers between 1 and 12. Or between 2 and 12. So notice here it doesn't reach 12 because 11 plus 2 is 13. It goes beyond that. I could also create both of these with the linspace function. So R1A, linspace does the same thing. I gave it the starting number, the ending number, but linspace doesn't need an increment. It wants the number of elements. So I want 4 elements. So this would create the same vector as this. Linspace, starting at 14, ending at 6, with 5 elements. This would give me the same thing. Linspace automatically will implement the decrement, or the minus sign, if the start number is higher than the end number. So you can use a colon operator or linspace. Sometimes you might want to pick one or the other, but they are essentially the same. Okay, that is the colon operator. Oh, I also want to mention, if you do not specify an increment, so I can say 1:6. If you do not specify an increment, if you only have a start number and an end number, it will give you a default of 1. So 1:6 just increments by 1 integers. And that's true if I had decimal points. So if I did 1.5 to 6.5, it would still increment by an integer of 1. And we'll see examples of that when it comes to our next problems. So that's the colon operator. I wanted to clarify that because I don't think I did a very good job of it on Monday. Good questions. Good questions. I get happy when I see questions. Okay, let's go ahead and create some matrices. So here I have a problem that says I want to create the following matrix. So A is filled with a bunch of zeros, and I want to change my last 2 numbers, so it's 37 and 47. So the first thing I'm going to do is I'm going to say A equals zeros. I'm going to have 4 rows and 7 columns. So I'm going to start out with A as zeros. So evaluate that selection. Here is A. Now I want to change this number and this number. So remember, we have 2 sides of our equal sign. We have what happens on the left-hand side and what happens on the right-hand side. The left-hand side, we're asking, where do I want to store numbers? Where do I want to store things? On the right-hand side, we are asking, what do I want to store there? So for this 37 in my document, I want to store in location in my matrix. So I want to change the value in A. So where do I want to store it? I want to store it in A. I don't want to store it everywhere in A. I only want to store it in a specific location. That specific location is going to be row 3, column 7. So in row 3, column 7, I want to store a value of 37. So over here, on my right-hand side, what do I want to store? I want to store a value of 37. Where do I want to store it? That's on my left-hand side. In the A matrix, row 3, column 7. So now if I execute this, my 37 shows up in row 3, column 7. Now I want to put the 47 in. Now I want to put in my 47. 47 shows up in row 4, column 7. So in my A matrix, in row 4, column 7, I want to store a value of 47. Yep, I'll mention that in a minute, Sophia. So once again, if I evaluate this, now I have my 47 that shows up. So Sophia made a good question, has a good question on when to use brackets versus parentheses. We're starting to get into more complicated programming where you're going to see the same thing show up in multiple different locations that means something different. So the semicolon we know has two uses. It's either used to suppress output at the end of every single line of code, so it doesn't print out in the workspace, or it's used to stack things on top of each other when we create matrices. Brackets are used to create a new array. Typically, you use brackets when you're creating a new row array and you're typing in the numbers manually, or you're creating a column array and you're typing the numbers manually. And that's when you use brackets, when you're creating a new array. Parentheses are used in a couple different contexts. One, it's used in mathematical expressions to force order of operations, to group things together to make sure you do this operation first. That's one of the places where we use parentheses. Another place we use parentheses is following functions. When we use a function, we type the name of the function like zeros, followed by open close parentheses. Inside of those parentheses, we send that function our data. So I want to use 4 and 7, two pieces of information. The first one is going to specify the number of rows. The second one specifies the number of columns. So that's the second place we use parentheses, when we are calling a function and sending it some input data. The third place we use parentheses is when we are indexing. So this is follows the name of a matrix or an array, where we identify what locations we're talking about. So A is my big matrix. I can follow A with open close parentheses to indicate that I'm only talking about part of A. So here I'm saying A, part of it in location row 4, row 3, column 7. So those are the three instances where we're using parentheses: to group operations together, to when we call a function, and when we are indexing or indicating that we're talking about part of an array. So yes, so brackets are used when you are making a new array. So here's another instance where I might use brackets. So I have this in 2 lines of code, where I did 37 and 47 separately. I could technically do that in 1 line of code. I could say A in rows 3 and 4. So here I have brackets to indicate that it's an array of rows. So this is an array that contains 3 and 4. And then in column 7, then I can put in these numbers. I want to put a 37 on top of a 47. Sorry. So this is how I could do it in 1 line of code, where here's 2 lines where I do each number separately. Here's in 1 line where I'm indicating with an array which rows I'm talking about. I'm talking about rows 3 and row 4. So in rows 3 and 4, column 7, I want to place a 37 on top of a 47. Note 37 and 47 is in that notation, or is in that orientation. There's a 37 on top of a 47. Same thing here. In rows 3 and 4, column 7, I want to put a 37 on top of a 47. So if I comment these out, and then I execute these lines of code, here we go. I have my 37 on top of a 47. So this is how I can do it in 1 line of code. There are other ways to do it in 1 line of code too. I could use the end keyword. So when I am indexing, when I am talking about locations inside of an array, I can use what's called the end keyword. Notice row 7 here is my last column. When I say row, I mean column 7 is my last column. So I can say row 3, 4, and I can use the end keyword. The end automatically identifies the last column in this instance. So I'm saying in rows 3 and 4, in my last column, place a 37 and a 47. So here's another way that I can do that same operation, where I can create this A matrix. I could do the same thing with my rows. So A, yeah, absolutely. So let's say instead of rows 3 and 4, I wanted to say rows 2 or 1 and 4. In my last column, I wanted to put a 37 on top of a 47. See what happens. Same thing. Just keep in mind, if I'm talking about 2 locations here, I need to give it 2 numbers. I think it will work without the semicolon. Yeah, it still works without the semicolon, but it's good practice to make it in the same orientation as well. Good question, Michael. So I could say that so in locations 3 and 4, I could say 3 and 4, whoops, but I could also use my end keyword for the number of rows. I could say end -1 to end. Oh, let me do the colon notation first. So I also, a lot of times we'll see the colon notation when it comes to indexing, because 3:4 is an array, oops, is array 3 and 4. So I use the colon notation a lot when it comes to indexing, but I could also use the end keyword. So I could say end -1, comma, end, just like Michael mentioned. This is also completely valid. There's like 1.5 million ways to do this. I could also say 3 to end. So there's lots of ways to do indexing. This might be a little overwhelming. You guys already have more questions than this morning, which is awesome. That means you're picking up something, hopefully more. But all of these are completely valid. None of these are wrong. There's many ways you can do things. Some ways are going to be easier than others when it comes to programming. But none of these are wrong. So if you, yes, you could also do a single number. So you could say location 27, it has to be in an array, 27, 28. So, and part of it is just try something. Like I said, there's a lot, there's a lot in this section, in these chapters. This stuff is very different from other languages as well. So there's a lot you can do. Pick something you know. Like if this one makes sense right now, where you do each number separately, stick with that one. If this one makes sense, stick with that one. The more practice you get, the easier it's gonna be for you to adapt. For someone to show you something like this and you're like, ah, that makes it a little bit easier. Let me do that one. So stick with something that you know right now, and that's perfectly fine. Stick with something you know, and you'll be able to, the more exposure you get, the more you'll be able to adapt and change. So if you do A1, so you have to comment everything out. So if like you have, if you did something like this first, and then you do 1, 4, end. Note the 37 shows up twice because this is first. So if you don't want to do something, comment it out. Okay, let's move on just because we have more things we need to do today. And you guys have really good questions, and so I want you guys to see other examples as well. Okay, let's look at D. So once again, D is full of a bunch of zeros. So I'm going to initialize it with my zeros function. There are 4 rows and I think 6 columns. Okay, perfect. D is full of a bunch of zeros. I want to change these zeros to 9, 7, 5, and 3. So for D, in my last row, so I'm going to use my end keyword because it's my last row. And then in these columns, so column 3, 4, 5, 6. So in my last row, I could say 3, 4, 5, 6. It's the long way to do it. I could just do 3:6. And that's the shorter way to do it. I could do 3 to end. There's lots of ways. Once again, stick with what you know. The more exposure you get, the more you do things, the more you practice, the easier it's going to be. I have 4 locations here. I have this location, this location, this location, and this location. If I'm doing it all in one line like this, I need to give it 4 numbers. I could type them all out and say 9, 7, 5, and 3. This is completely valid. I could also create this array on this side however I wanted. I could say linspace, like Wilcox mentioned, starting at 9, ending at 3 for a total of 4 numbers. This also works. I could use my colon operator, starting at 9, incrementing by -2, ending at 3. Another completely valid way. Just keep in mind, if I have 4 numbers over here, I need to give it 4 numbers over here. There's one exception to that. So identifying over on my left-hand side, what am I trying to change? Where am I storing my results? On the right-hand side, what am I putting there? Keep in mind, if you have 2 numbers over here, you need 2 numbers over here. If you have 4 numbers over here, you need 4 numbers over here. Okay. The last one I want to create before we get into some other stuff is B. So here's B. Notice it's full of a bunch of zeros. So I'm going to say B equals zeros, 4 rows, 5 columns. Now it's full of zeros. I want to change row 2 to a bunch of 2s. Okay, so here's row 2. I want to change it all to a value of 2. So B, open close parentheses. Where do I want to store my results? I want to store them in my B matrix. I don't want to store it in all of B, only part of B. So I need my open close parentheses. What rows? Row 2, only row 2. What columns? There's a couple ways I can do this. I can say column 1, 2, 3, 4, 5. I could say 1 to 5. That is one way I could do it. Another way I could do it is say 1 to end, where starting at column 1 all the way through the end. The most efficient way to do it is just a single semicolon. So if you're ever talking about all of the rows or all of the columns, put not a semicolon, put in a colon. Look at what I type, not what I say, right? So I can use a single colon to indicate all of the rows. Rows 1 through the end. Columns, to indicate all the columns. Column 1 to the end. Same thing for rows, but right now I'm talking about columns. Okay, so what do I want to store there? So in row 2, all of my columns, I want to store a value of 2. This is one of those exceptions where technically I have 5 locations on my left-hand side, but I only give it 1 value on my right-hand side. If you set multiple locations to a scalar, then this 2 is going to be copied into every single location. So when I do this, now my second row is a bunch of 2s. Okay, so now I've got my 2s. Now I want to go ahead and set my last column to 1, 2, 3, 4. So once again, where do I want to store my results? In my B array, in all of the rows. So I could say 1 to 4. I could say 1 to end. If I'm talking about all of the rows, though, I could just say a single colon. What column? My last column. So I could say 5. I could say end. What do I want to store there? Numbers 1, 2, 3, 4. So 1 through 4. So if I execute this, there we go. First B is a bunch of zeros. Then my second row was changed to 2s. And then my last column was changed to numbers 1, 2, 3, 4. So when we look at that equal sign, there's 2 sides. My left-hand side. Where do I want to put things? On my right-hand side, what do I want to put there? Those are the 2 questions we're really talking about this week. Where do I want to store things? What do I want to put there? Keep in mind, if you have 2 locations or 2 places you want to store things, then you either give it 1 number that's going to be copied into both locations, or you give it 2 different numbers. If you have 4 locations, you need to give it either one number that's going to be copied everywhere, or you give it 4 individual numbers. And like I said, sometimes you just need to try something. Sometimes you just make a change, execute it. Like I said, I'm doing a lot of highlighting it, right-clicking, evaluate selection. That's a pretty good debugging technique, especially in MATLAB, because you can do that, which is amazing. So even with like expressions and long calculations, just kind of highlight something, be like, hey, what does this give me? Evaluate it, be like, oh, yeah, you're right. That does look like that. What does this side look like? Oh, it's 2 numbers on top of something. Great. So sometimes you just highlight it, execute it, try something, and see what happens. Your errors mean something. I don't have any errors right now. But let's say we had, let me clear everything. Let's say I had, in 2 locations, I have 3 numbers. So let's say 37, 47, and 57. So if I execute this, and I get this error, unable to perform assignment because the size of the left side is a 2x1, and the size of the right side is a 3x1. So if I right-click and highlight it, say evaluate section, I can see that 1 and forward end is only 2 numbers. If I right-click and highlight my right-hand side, I can see it's 3 numbers. So I can't put 3 numbers into 2 spaces. Okay, so your errors are they try to be meaningful. They try to give you some idea about what is going on. So use them. Yes. Okay. Oh, oops, wrong one. I think Matt asked a question. We're gonna use this to solve equations, won't we? Next week, we are gonna get into how to use arrays in mathematical expressions, which there's some caveats to that when it comes to MATLAB. So it's important. But yes, next week we will get into that. And this week we're all about creating arrays, modifying arrays, changing locations, doing lots of fun things that make things a little more challenging. Okay, but pay attention to what your errors are. They try to give you an indicator about what is wrong. Okay. Okay, I wanted to go through some of the challenge activities that you don't have to do in MATLAB. So you don't have to do the challenge activities in these sections. It shows up in your assignments. So if you go to the assignments tab and you click week 3, there's a down arrow. It shows you everything you have to do. If there's an orange flag next to the section, that means you need to do the challenge or do the participation activities. If there's a blue flag, that means you need to do the challenge activities. So you don't need to do them in these sections. And like I said earlier, before class even started, in 4 and 5, they get pretty challenging. It's pretty exciting of the things we can do. So I'm going to go through some examples just to illustrate some programming concepts. So first, I want to go through challenge activity 4.2.1. So it looks like this, and the goal of this challenge activity is to, given a square array, so an array with the same number of rows and columns, we want to return the center element. So if square array looks something like this, if it's a 3x3, 3 rows, 3 columns, then I want to return the middle number, which in this case is a 5. So notice when you write functions, you don't know what your input is going to be. You don't know what square array is going to be. Your description in your challenge activity tells you that it's going to be an odd number, odd size matrix. So it's going to be a 3x3, a 5x5, a 7x7. So square array could look like this. Square array could look like this, where you would return the 3. Square array could look like this, where it's a 7x7, and you return this 6 here. So notice, if for a 3x3, my center element, this one, is located at location 2, 2. If I have a 5x5, my center element here is located at row 3, column 3. If I have a 7 by 7, then it's located at here, which is row 4, column 4. For this problem, there's like, you know what to do. You know that if it's a 3 by 3, you need to return the location 2, 2. You know if it's a 5 by 5, you need to return the element in row 3, column 3. If it's a 7 by 7, you need to return the element in 4, 4. But the difficult thing with programming is it doesn't tell you how you're going to do that. How are you going to figure that out? As a human, you would just say, oh yeah, it's that number there. I can see it. It's equal on both sides. Like there's 3 here, there's 3 here. It's equal on both sides. Not an issue. But as a programmer, you need to figure out how to tell the computer to do that in a consistent way. So we need to come up with a method in order to do this. This is where it might be helpful to look at those other functions that are listed in your notes. The size function, the length function, the numal function, the endims function, where what we can do is we can ask the array, how big are you? What's your length? How many elements do you have? How many dimensions do you have? So for this one, I can ask the array, I can say, hey, square array, how many rows do you have? So rows, I can use the size function, SQUARE, array, and the first dimension. So here, I can use the size function to ask my array explicitly, how many rows do you have? Comment. Asking how many rows do I have? Notice I'm asking the array itself, because square array is going to be different. It might be a 5 by 5, in which case it would tell me it has 5 rows. It might be a 7 by 7, in which case it tells me it has 7 rows. It might be a 3 by 3, in which case it tells me it has 3 rows. Regardless of what that number is, I'm going to use it in order to figure out what the middle one is. So if it's a 3 by 3, I need to get to a 2. If it's a 5 by 5, I need to get to a 3. If it's a 7 by 7, I need to get to a 4. There's a couple ways I can do this. One way is I notice that every time 3 to a 2, 5 to a 3, 7 to a 4, what happens is I'm dividing the number of rows by 2. For a 3, that gives me 1.5. For a 5, that gives me 2.5. For a 7, that gives me 3.5. So I'm always a half off. So I'm just going to add a half back. So this is what I can do. This is going to be my algorithm in order to figure out where is my middle location. Chat is dead. So rows here is going to ask my array, how many rows do you have? Whatever that number is going to be stored in this variable. So rows could be 3. It could be 5, it could be 7, it could be 9, it could be 23. Whatever that number is, I'm going to, there we go, divide it by 2, and then add 0.5. So now if square array is a 7 by 7, element index is going to be 4. Because 7 divided by 2 is 3.5, and 0.5 plus 0.5, it gives me 4. This is one of the ways I could do it. There are other ways. So Michael, that's a good question. This function, or the description tells me that n, the number of rows, is always going to be odd. So a lot of times when you're writing functions, you just need to assume that the user knows that it's going to be, that they need to enter in an odd array. But this one describes that we should only expect arrays that are odd numbers. Chaz H mentioned a good point of using round. So we could also use a series of round functions. So I could just say round. Round will also give me that same number. Oops. Round will also give me 4. I could also use ceil. which is for ceiling. So it just ensures that it rounds up. I could also use floor +1 if I only want to deal with integers. So there are pretty much always multiple ways where you can do the same thing using a different set of rules, but it's all valid. Space engineering student, yes, you can use if statements in order to essentially check to see if your input is correct. We will not get to if statements though for a couple weeks. So I don't want to show you guys anything that you don't know about yet, but that is completely legitimate. Okay, so there's multiple ways we can do this. But the key point is, in order to do this problem, we have to come up with a solution using the rules that we know and making sure that it's generic, to where if it's a 5 by 5, I can get 3, 3. If it's a 7 by 7, I can get 4, 4. If it's a 23 by 23, I can get 12, 12. You could also add 1, I just thought another way, add 1 to the number of rows and then divide it by 2. Okay, so there's lots of ways to do this. Once I figure out what that location is, then I can go ahead and say SQUARE, array, and then I want that index. So now my middle element, if it's a 3 by 3, I'm going to grab location 2, 2. If it's a 5 by 5, I'm going to grab location 3, 3. If it's a 7 by 7, I'm going to grab location 4, 4. So like I said, we're starting to get into the harder parts of programming where no one tells us exactly how we're going to do things. We kind of need to come up with it ourselves using a set of rules, using the knowledge that we know to date. Okay, let's go over GenMat border. So this one, there's not much description, but this is challenge activity 4.5.3, and what it tells us to do is it tells us to create a 0 border for my InMat. So let's say InMat looks like this. 6 rows, 9 columns. It essentially says make the first row and the last row zeros, and the first column and the last column zeros. So there's multiple ways we can do it. We could do it one at a time. So in mat, I want to change part of it. I want to store zeros in certain locations. In rows 1 and my last one, all of my columns, I want to put a 0. I could do this in 2 statements. I could do row 1, make it zeros in 1 statement, and the last row in 1 statement and make it zeros. But here I'm talking about in my InMat matrix, I want to modify, I want to store in these locations a 0. Row 1, row end, all columns. Same thing for my columns. In mat, all of my rows now in column 1 and the last one. So InMat currently looks like this. If I execute this line of code, notice it makes row 1 and my last row all zeros. If I did this one, it makes column 1 and my last column all zeros as well. Like I said, you can break this up so that you're just saying InMat row 1 all columns equals 0. InMat row end all columns equals 0. This does the same thing as this. It's just in 2 lines of code versus 1 line of code. Go with what makes sense. You also might start by programming something and then realize, oh, there's an easy way to do this, and then rewrite your code. That's totally fine. There are so many times where I write code and then I'm like, there's a better way to do this, and then I rewrite it. That's completely fine. Go with what you know. As you practice, as you get more complicated, as you get more exposure to the material, you will get better. You will get more efficient. Someone might show you something and you're like, oh, that makes complete sense now. I understand. That's fine. Learning programming is incremental. You start as a beginner and you work your way up. Okay, so let me go ahead and call this function from my command window. So let me recreate my inmat matrix. So now my inmat looks like that. A equals gen mat border inmat. And I expect it to work. It should work, right? But I get an error. It says output argument outmat and maybe others not assigned during call to gen mat border. So this error indicates that my output argument is called outmat, whatever that variable is, wasn't assigned. That means somewhere I didn't say outmat equals something. And if you notice, I don't have anywhere that said that. MATLAB gives me these warnings. It says the function return value outmat might be unset. So I need to say that outmat equals inmat. I can do it at the beginning, I could do it at the end. Either way, I need to say that outmat equals my final answer. So I save it, rerun it, now I can see it works again. So like I said, your errors, they try to tell you what is an issue. Here it tells me that, oh, I forgot to say that my output variable equals this. Sometimes you might name it differently. So if this is just O, but you called it outmat, it will also give you an error. Okay, we have 4 minutes left. Delete row, column. Okay, so for this one, I'm gonna go through an example first. For this one, it tells me that I have an original matrix. So let's say A looks like this. Say A looks like this. There we go. And del row is 2, and del col is 3. Your Zybooks typically gives you an example. Write that example out. It will help. But for this function here, what I'm going to do, or what I need to do, is I need to take my original matrix, and I want to delete the row defined by this variable, and delete the column defined by this variable. That's relatively straightforward. So org matrix A, if I'm going to delete this row, the row defined by del row, in this instance it's row 2. If I'm going to delete row 2, it looks like this. Where row 2, all of the columns, I want to set them to empty. Start with an example. Just know that it's not always going to be row 2. Del row might store something else. So this 2, I'm just going to replace it by del row. Whatever row is inside of that variable. And I'm going to assume that the user, that it's a valid row. Like they're not trying to delete row 12, because row 12 doesn't exist. Same thing to delete my column. Org matrix A, I'm going to delete column, in this example, I have a column 3. But keep in mind, it's not always going to be 3. It's going to be whatever del col stores. So I'm going to replace my 3 with my variable. So that's the first thing I want it to do. I want it to delete that row, delete that column. And then before I forget, new matrix A is going to be my original matrix after I've deleted everything. Okay. So that's the first thing I want my function to do. The second thing I want my function to do is I want to keep track of the elements it deleted. So if I'm deleting row 2 and deleting column 3, I want to have a second vector that keeps track of these elements. So I want deleted elements, I'll short name it D, to contain those numbers, 5, 6, 7, 8, and then 3 and 11. So that means before I delete my row, I want to store those numbers in a separate matrix. So deleted elms is going to be that row. Org matrix A, del row, all columns. So before I delete them, I'm going to just store them in a separate matrix. Then I can delete them. Then before I delete my column, I want to store those elements inside of my deleted elements as well. Okay, so I'm going to illustrate some fancy stuff. Before I explain it, let me go ahead and just type it out. Okay. So there's a lot going on in this line of code. We've got negative minutes to explain this. Del row and del call, those are input arguments. So del row is going to be defined by the user when they call the function. So if they want to delete row 2, they would say delete row 2, where 2 would be the input argument. Del call. So they would say delete row, column, whatever your matrix is, and then 3, 6. So in this instance, del row would be 3, and del call would be 6. So those are just variables, those are just inputs that define what my user wants to do. Define what my user wants to store in these variables in order to do to execute the code. Hopefully that made sense. Okay, so let me quickly explain this before we finish. Sorry for going long today. But what I'm doing here is, here I'm saying I want to actually grab those numbers, the deleted column. Same thing I did here, where I'm actually going to grab those numbers and store it in this new array. Same thing here. I'm grabbing those numbers. I'm transposing it because these numbers are a column and I want it to be a row. And then I'm just appending it to deleted elements. So essentially, it's as if I did this. Temp equals this, where I'm saying take those numbers that I'm going to delete, store them in a temporary matrix. And then here, deleted elements, I'm just going to do some concatenation, where I'm going to take the original elements and store them and place them next to my deleted row elements. So I could say deleted rows. I could call this deleted column elements, so that my deleted elements is going to be my deleted row elements placed next to my deleted column elements. This probably makes the most sense in terms of your guys' understanding, but there's a lot in this problem. But you can see that we're starting to get to more complicated problem solving. We have lots more complicated expressions, a lot more complicated things that we can do, and it complicates how we start to solve these problems. Keep in mind, this is sequential, so I need to grab the numbers before I delete them. Same thing here, I need to grab the numbers before I delete them. If none of that made sense, don't feel bad. Like I said, as you get more exposure to the material, as you play around with it a little bit, things might start to make sense. But there's just a lot that we've gone over today and Monday. Okay, with that, I am done. I will stick around for any other questions. If you guys want to know, so Remy, if you want to know the solution for inner leave mod, I have it here. I can go over it if you want, but if not, I am done. So, DM Kata, if you go to Zybooks, there's an assignments tab, and it shows you, if you have the down arrow, it shows you everything you're supposed to do. So it shows you all of the activity, or all of the sections you're supposed to read. If there is a orange flag next to it, that means you need to do participation activities. If there's a blue, that means you also need to do the challenge activities. But you don't need to do the challenge activities for 3.8, 4.2, 4.5, and 4.6. We went over some of those. You can see they're more complicated. Homework 2, we should submit problems 3 and 4 as function names. Yes, for problem 3, you're submitting a file named Parabola. For problem 4, you're submitting a file named Torus. Like I said, we're in week 3. You guys can do it. I believe in you. Play around with the material. They are all .ems. If you do rand I with one number, it gives you one number. Gives you a number between 1 and that number you typed in. It's fun. So for functions, name and date, put that below your first line. So you could say function, whatever. I did an example of this last Wednesday. If you want, go back to the lecture videos, scroll through it, you'll see an example. But just if you want to putting your name and date in, just make sure it's below the first line, somewhere in that block of comments. So AP Cruzy, your Randi, just try it. Sometimes you just try it, see what happens. For problem 3 and problem 4, or homework 3 and homework 4. In the last exercise, shouldn't the row and column be saved before deleting the column? Yes, that's why I had those 2 variables, deleted row elements, deleted column elements, before I deleted them. So for part 3 and part 4, so you have 4 files to submit for homework 2. You have HW2P1 underscore UBIT name, HW2P2 underscore UBIT name, parabola, torus, all .m. It says at the top of the homework document, script files need to be named in that specific way. Function files need to be named the same as the function. So ignore the recitation problems in MATLAB Grader. Those are for Dr. Ali's classes. I am doing live lectures. I'm doing those comprehension quizzes. Those are just for him. Ignore those. Yes, AP Cruzy, that is bad. Comments, your first line of your function needs to be the word function followed by your function definition line. So all comments need to be below that line. I know, I changed the layout this morning, and then I realized some of it was wrong, and I needed to modify it again before today's lecture. I'm trying. I'm new to Twitch. I'm trying. It's great. I love it. Teaching class like this is so much better than using Zoom. I hope you guys like it too. I assume so. There's so much more discussion. I really appreciate it. Any final questions before I head out and get lunch? Okay, have a great day, a great week. I'll see you guys on Monday.